Okay, awesome. So to give some context behind this pull request joke, there he is. There's Jose. So I did some Phoenix Guide training the last couple days, first 2 days of the conference. So I was just 8-hour training, a couple days in a row. We had a Phoenix Guide sprint effort going on meanwhile, which I'll talk about, which was fantastic. But second day of the guide effort, Jose spent his entire afternoon, instead of doing useful things, getting almost every person I interacted with, like dozens of people, to submit the tiniest pull request possible to the Phoenix Guides. Only so I would, everyone but me submitted a pull request, basically. And so that's the big joke. But it was like the level of effort he went to, like throughout the day, became more and more apparent. Like even the other trainers that were predisposed all day also submitted pull requests because they got an email from Jose. It was like caps important. So everyone but me contributed. I'm pretty sure at this conference. So anyway, well played. But we're talking about what's next for Phoenix today, and a little bit about Phoenix 1.3 that we have heard before, but some lessons learned now that it's out, and kind of where we're headed going forward. So before I get started, obviously we just heard the plug from Dockyard, but I do have to thank Dockyard for really allowing me to balance my life out and work on open source the majority of my company time. So they've really invested in the community and in Phoenix itself. So please check us out. We do Elixir and Phoenix development, anything from greenfield architecture engagements to training. So we owe them a big thank you. But before I get talking about Phoenix, I do want to talk about some kind of rebranding effort that I started just today, because Jose did a little bit of goal rebranding with Elixir, and they changed their goals from being productive, extensible, and compatible to productive, maintainable, and reliable, which I think is great. It sounds good. And I was thinking this morning, like, oh, this sounds really good. And I was like, wait, it sounds really good. Like almost too good. And then I was like, they still all we had all the best words, and they stole almost all of them. So, yeah, right? So, I mean, Jose calls the shots, Elixir sits on top, right? So we're gonna have to do a rebranding effort, other than fast, that's all we're left with, but I think that goes without saying now. So I was thinking, like, what are we gonna do? But we can just steal all the other best words back. So Elixir was productive, extensible, and compatible. So now Phoenix is productive, extensible, and compatible, right? I mean, we're productive just like Elixir still, because everyone loves being productive, and we can always improve that. And we're extensible because people think like, oh, Phoenix takes over your app, but no, it's like we're actually really extensible. We can just serve the web component of your app. People can use us to build apps and subscriptions. Like we're very piecemeal, we're very extensible. And we're also compatible, right? We're built on top of Plug. So if you want to use a Plug library, you can just drop that in. We're compatible with Cowboy and Cowboy 2 and the LE plug adapter. So I think we really can just take over these words and just do a swap. So thanks, Jose. All right, so Phoenix 1.3. I'm sure you're wondering, like, wow, I've heard about Phoenix 1.3 like last year. And I'm going to talk about it today a little bit because it's 8 months late, give or take a couple months. I want to talk about why this took me longer than planned. And before I do that, I do want to highlight that we have a context guide that's live. That took quite a bit of work, and we're really happy with where it's at. So if you haven't checked out the new Phoenix guides, they're all on Hex Docs with a new context guide. So while you're waiting on the new Phoenix book to be updated, we're planning on having that come out by the end of the year. Do check out this guide, because I do think it will fill the gap between the Phoenix 1.3 ideas and the Phoenix book. But why did this take longer than planned? Because we just talked about, okay, we're going to have new generators, we're going to focus on code that pushes newcomers in the right direction. Sounds pretty simple, but we were trying to answer a pretty large question in retrospect, and that's like, what makes a good Elixir program? And if you try to poll everyone in the audience today, you'll probably get 1,000 different answers. And worse, we were trying to answer like what makes a good program in general. Like it turns out trying to solve this generic generator question was really encompassing the entire field of computer science and lots of differing opinions. So it took a long time to try to find the right balance of how do we distill what it means to make a good Elixir program into a tiny set of rules that we can apply broadly to newcomers, to people that have been in the language for years. And that's a really difficult task in retrospect. But I'm pretty happy with where we ended up. So ultimately what we want is code that's easy to write, easy to understand, and easy to change. And I think that's pretty easy to distill those rules in what we want when we write software. And I think up until Phoenix 1.3, we were focusing on code that's easy to write, definitely. I think people felt productive. The code was pleasant to work with. But I think code that was easy to understand and easy to change was kind of hand-wavy, at least long-term. It wasn't so hard to understand, but trying to maintain something down the road with our current, or with our 1.2 generators definitely led people down an unmaintainable path. And that wasn't clear to us initially because, as with any young community, we release tools and then we see how the community is reacting to them at consultancies with like Elixir and Dockyard, or like Platformer Tech and Dockyard. We get client applications that come in from teams that need help, and we kind of see the ball of mud that people start creating. So the Phoenix core team said, okay, we need to address some of these issues that people are having code that we're inheriting that's really difficult to understand, and teams are having trouble changing and refactoring their code. And we find out like programming is hard, but teaching programming is harder. So if you ever tried to teach programming or have written any kind of technical document, trying to teach someone rules that are going to level them up to the place that you want to be is incredibly difficult because we have our current holistic understanding and we're trying to distill that down and bring them step by step up to where we want to be. So that was kind of the task of the Phoenix team when it seemed seemingly easy just to write some generators. It ended up being us kind of trying to teach people how to write maintainable programs. And that's really hard because how do we distill that down? And how do we get that right in a way that's going to work broadly? Because for me personally, coming into functional programming, it's like, what does it mean to write a good functional program? And I have a lot of baggage, and I think a lot of us do, coming from object-oriented backgrounds. Like historically, like my entire CS program was all about object orientation. So I had views in my head when I would take classes in college that, like, wow, the people that came before me, like this Gang of Four book, these authors, they figured it all out. So there's decades of research and effort that have gone into programming, and I would have thoughts like, wow, I wonder what it would have been like to be alive a few decades sooner and like actually figured out these problems, like the way to program, because you take these things at face value, like this is the way to do it. And then you come into functional programming and you're like, oh, what about the Gang of Four book for FP? Like, where is it? And it doesn't exist. So for me, like my own learning journey, I kind of had to like throw away some old concepts. And I think a lot of us have to do that, whether it's coming from another language to Elixir or coming from another framework into Phoenix. You kind of have to discard that there is a way to do something and rethink. I think that's hard for people. And we like to say in functional programming, like, oh, we don't have design patterns. We just write modules and functions. That's all we do. And it sounds great. I say that all the time. But if you're a newcomer, you hear that and you're like, okay, this is not helping me at all. Like, this doesn't tell me anything about writing a program. But it sounds good. It sounds catchy. So I think it's not enough for us to just say write modules and functions. So we've gotten some backlash on why did you name this special thing in Phoenix 1.3 called context? Like, why did you have to come up with a new idea? And I hate the name context. So naming things is hard. But anyway, we named something, we gave a name to a new idea because we can't just tell people write modules and functions. That's not a rule. That doesn't tell them how to write good programs. So that's where we came up with this idea, like how do we distill down all of computer science, all of these ideas in the field of structuring programs into something that's broadly applicable? And what's the smallest step we can take? And that's where contexts come in. And contexts are just dedicated modules that expose and group related functionality. And that's it. So they're modules and functions, but we want you to think a little bit about how they're grouped and how they expose different features in your application. And along with that, we also focus on a directory structure that also kind of screams the intent of your application. And we made a switch right before Phoenix 1.3 was out that we actually moved the web directory outside of, we separated your application code lib directory from your web code in the lib directory. This was a very late in the game change, but I'm glad we did it because this further kind of signifies that your web application is entirely separate from your actual application, the code that drives your business logic, the thing that your app does. And we also go further than that and say, I want to be able to look at an app when a client comes into Dockyard or when I help someone try to debug an application. I want to be able to look at them and say, okay, I don't know what this application does yet. I'm not going to open the web directory yet. I'm not even going to see like what the controllers are doing. I'm just going to say, okay, look, let's look at the directory structure. I can see that this app can do notifications. It has a sales system. Looks like it has a blog. And then if I check out the public interface for those modules, like they should tell me what they do without even trying to get a full understanding of the code. I can see that, oh, I can handle refunds here. Looks like I can get purchases from some kind of data storage. I can send notifications. Oh, it looks like I can send SMTP emails, push notifications, and SMS. So the goal is to get people in this direction of now I can understand the code easily, and this code is going to be easier to change because the moment I want to talk to Twilio within my notification system, if I want to use Mailgun or use SMTP, I can easily change that piece of code in my notification system without finding the controller or channel that's calling Twilio directly. So our goal is to get people here, and we think this is a small enough step and a general enough rule that this is how you can write software, right? Just like the Elixir standard library has a logger module that you can log stuff to the console, there's other code in there that does other things, right? But we interact with it through a public interface. We want people to get thinking about writing code in a well-named module and function and grouping related functionality in their application. But it's a balance because what happened was people before, when we went to the release candidate, there was some pushback where people were saying, this is literally going to be the death of Phoenix, to like, they were like, you know, it was like a hot and cold type thing. Lots of good feedback, and then occasionally like, this would literally kill you if you use it. But by and large, I think it's been very positive. And even talking to people here at the conference, I've heard that, you know, I've heard comments like initially this was a barrier for me, but I really tried to internalize these ideas, and now I love the way my code is turning out. So to kind of illustrate that, I was talking with Sean Washington on Slack. He's not here today. But we had a really good conversation. It was actually just before the conference about someone struggling and then kind of working through this new thought process and then ending up in a very good spot. So like most people in Slack, he posts a question because if you're on Slack and you need help, well, we're here to help you. So he said, I'm struggling to think up context wrapping for social actions. So any newcomer comes in and we tell them, okay, we want you to think. And then they're like, but I don't know what to do. And sometimes they get decision paralysis because even if they have the best of intentions, we're telling them it's important that you make a decision, it's important to think about your application design, and then they start thinking like, I can't make a decision because I'm afraid to make the wrong decision. So we do have this barrier, but we think with a little bit of effort, people can get past it and end up in a really good spot. And if you went to Keith's talk earlier, which was excellent, I like his pit of success analogy that I'm going to steal for the end of time now. Because our goal is we want to have newcomers come in and you're going to stumble, right? When you're learning anything new, any new technology, any new API or framework, you are going to stumble. But we want you to stumble into constant success versus pits of despair. And one example of that is Jose and I actually have people tell us that they'll run into issues, like they're learning channels or they're learning parts of Phoenix and they'll get an error message. And that error message could be a pit of despair. Like any error you get could stop you from continuing for hours. But we'll hear people say that they just followed the errors and it told them what to do and what to fix, and that's all they had to do to end up with a working program. So that's kind of, I like this pit of success scenario because you're going to stumble, but we want you to keep stumbling into pits of success where you're like, I stumbled, and then like if you try to push a message in a Phoenix channel join, you can't do that. But instead of just like argument error like you would get from Erlang, it's like, hey, you tried to push and join. Here's why you can't do that. Here's what your code should look like if you want to do a push and join. Send yourself a message and handle info. And anyway, so we want people to constantly reach a successful point when they're struggling. So when Sean said, I'm trying to name this context, I don't really know what to think, like what to name it, where this thing should live, what he did immediately, he's like, well, maybe I just put it under my existing account context. So it's nice that he at least said, I'm not thrilled with this idea, but I want to make forward progress. I had to think about where this should live in my system, so maybe I'll just add this function. And he even said, I don't like that name, but I'm on my way. So at least he had to think about where should this live in my system? Like my app's still coming together, but I'm going to make a decision to place it here. And I was online and I said, Sean, I actually have a talk at Lone Star Elixir with this exact question of like social actions. And I said, what if we made the API reaction add-like? What if you introduce a new context? Because accounts in the system, is really, our social actions really grouping functionality into like user accounts? Maybe we can have a separate context here that encapsulates that functionality. And maybe it could look like this, where instead of having the accounts have like a like post for user, we could just have a reaction add like, and then that could hold its own ecto schema table, so we wouldn't have to worry about polymorphic associations. The reaction can handle all of that and know which kind of data structures it supports. In this way, we're grouping that functionality and providing a clear interface for it. And Sean was like, oh, wow, this like almost seems too easy. And he was in a good spot. So it was like he hit the little barrier, we talked through it, and he ended up in a happy spot. And he even told me later that when he was testing it after the fact, that it became incredibly clear. His tests became much better than they were before. So he encountered a little bit of resistance, had to do a little bit of thinking, and ended up in a very, very good spot. But it was even cooler because we continued, where he was like, he's just building his app. So he was like, okay, that reaction stuff sounds cool. And then he was like, well, what about caching? So it was kind of cool to see like why it's important to think up front about design. So we thought he's like, oh, by the way, I have this requirement. I have to cache the number of posts or the number of likes a post has. Like, would I do that in something like counter caches? And this is where like keeping preconceived assumptions from other technologies, like if you've come from Active Record in Rails, counter caches are what you use. That's what I've used in the past. You're like, everyone that I know use counter caches, and that must be the way to do it. And I was like, well, we try to avoid counter caches, but then Sean was like, you know what, wait a second. Like, this doesn't make sense, because he's starting to think about grouping functionality. And he's like, well, if I have to introduce counter caches, I'm going to have fields that leak throughout the app that are concerned with caching. So like, if I have community content with posts, I have to introduce a couple fields here, like likes count, loves count. If I add like a rage face, and then I have to have a rage face count, it's like this is going to get ridiculous. And like I have to introduce that for every entity in the system that cares about it. And now it's leaking across the group functionality of my app. So it became apparent once he started thinking about this just like generalized rule that maybe we could have the reaction module that takes care of likes and dislikes contain the caching information. And that way we can just expose the stats over the common API. So if I like a post or I want to get stats for a post, the reaction knows how to do that and handles the caching internally. So he ended up, it was really neat for me because it went from like I'm struggling to at least I can make forward progress to wow, this sounds good. And then as he added features to the app, it became apparent that the new direction was driving him in a proper mindset. And then he wanted to come and live on my floor in my office to soak up all of my apparent knowledge. But I had to break the bad news to him, like, this is my current home office. So studs and drywall and heavy machinery. I'm undergoing renovations, so he's more than welcome to sleep there if he can find a spot. So that's interesting. So I get comments from newcomers that reinforce the idea that we're definitely on the right path. And what's the most interesting thing for me since we released Phoenix 1.3 is expert teams have also been affected by this. And this has been the biggest surprise for me. So Sasha Urich is the author of Elixir in Action, probably one of the most talented and skilled members in the community. And I'm going to walk you through a story that he shared on the Elixir forum where he said, a year ago, his team started working on a Phoenix app, and they all had experience building Erlang systems, web servers, a lot of non-trivial software, just software development in general. So these are expert developers. And none of them had experience with Phoenix, but they followed all the best practices that the community had, which you do, right? You follow blog posts, you follow what books are saying, you follow what the official guides are saying. And they started with Phoenix 1.1. There were no contexts then, and they moved quickly. They wrote a lot of code because they were really productive, as you do, right? But the problem is, later on, they were like, suddenly, like each iterative step, you're like, okay, this feels good, I'm productive. And then suddenly you realize my code is really interleaved, there are no clear responsibilities in the app, and it became increasingly harder to maintain and extend. So expert team followed best practices, ended up implicitly following what at the time felt good. So the framework decisions, even our code generators were pushing expert teams in a wrong direction. And 6 months later, they come to find out that, wow, we're in a point that we really need to clean up. And unfortunately for them, like what's clear to me is, like he said, to this day, our code is still not completely refactored. So they tried to go into this service module approach, which is kind of similar to context. Let's try to, figure out where we can isolate different functionality in our app that's grouped together. And 6 months later, they're not there yet because it's really hard to change software, especially software that is interleaved with no clear boundaries. So he has some takeaways, which I've summarized a little bit, but there's a link at the bottom of this slide if you want to check it out. But I think it's really important to go through these. One is he says the framework plays an important role in determining code organization, even for experienced teams. And to me, that's been the most surprising thing. So the tools we use, whether it's Phoenix, whether it's Mix, they're informing our code decisions, even if we don't realize it. So even though this team wrote non-trivial programs, even though our code generators just give you this like really basic starting point, they don't write your whole app, that was still nudging them implicitly in a bad direction. And I think it's obvious now, but it's harder to refactor code after the fact. And Sasha feels that your chance of keeping control of your code, you have to pay attention to it from the very start. So we've gotten pushback from people that say it's not important to have our generators focus on these things from the start. People can get into them later. But again, to go in this pit of success scenario, like we want them to fall into a good design and maintainable program. We can't have them fall into this pit of despair, unmaintainable mess, and say, oh, now here's what you should have done. We have to focus on these things from the start. And then he said that keeping Phoenix part of just the web-related task in your app is kind of an interface to the rest of the system is a good way to structure any production app. So that's kind of what we're trying to push folks towards. Like Phoenix is great, but have that be a window into the rest of your system. Don't write your business logic in your HTTP interface. So that was the most interesting takeaway for me for Phoenix 1.3. I think by and large, I've had great feedback. Client projects that have come into Dockyard with teams following these scenarios have been way better. So I think we're seeing definitely success in the community from these. And then talking to folks at the conference, I've even heard quite a bit of success stories. So beyond that, I want to talk about Phoenix 1.4. I mentioned this in Barcelona, but I want to talk a little bit about our plans going forward. So we want to focus on monitoring metrics because we see some problems coming about, especially related to web applications. I mean, every web application, every company wants to say, okay, like, where is the app slowing down? Where do I have slow database queries? If the 1% of my users start experiencing a slowdown, that's going to directly affect my sales. So we have a lot of companies that take care of this for you. So there's Datadog, New Relic, AppSignal, Skylight. These are great companies. They serve a great role. But the problem we've seen is all these companies implement their own data collection agents that run on your server. And all of them usually provide clients on different platforms, whether it's Ruby, C#, and Elixir. So we were seeing a lot of duplicated efforts to integrate with these different services and a lot of data collection that was happening that didn't really treat the Erlang VM as the novel platform it is. So the idea for us is to have the Phoenix team focus on having some common interface. So all these are referred to as application performance monitors. So we wanted to provide some basic, boring APM library that Phoenix, Ecto, XAWS, plug, every library that wants to report metrics in the Elixir ecosystem can depend on. So instead of saying if you want New Relic support, you have to kind of try to shim some library, we want to provide a common interface that handles the data collection in the best way for the VM. So we want to make sure it's fast and efficient, and also make sure we collect information that's relevant to the novel platform that we have. So if you're using Phoenix or Ecto or Plug or XSOS, they can report to this, they can use APM to collect the data, and then we can configure data reporting to Datadog, New Relic, AppSignal, so we can handle the collection side and then report to whatever third party that you need. So that's one problem we want to solve. And the other problem around this is this issue. And this is a caricature, right? So these modules don't exist. So don't go open an issue on AppSignal. But what we're seeing is these companies rightfully want to have a first-class experience in Elixir. So they want to say, you know what, we can track your database queries. We can let you know where you have a slow query. So all you have to do is use AppSignal repo metrics. Again, fake module, but still the point applies. And then New Relic's like, hey, we actually have Elixir support too, and a lot of people use Ecto, so you can use our Ecto metrics. We're going to do some code injection here and report. So we're seeing, again, all these duplicated efforts, and they lead to a lot of nasty hacks with code injection. So the goal is, well, if we could just have Ecto rely on this interface, you could configure AppSignal or Datadog, and then Ecto can just say, here, report this statistic. And if no one's configured for it, it can no-op. Otherwise, it can report the data to all these services. And then we also want to do this in the most efficient way possible, because the problem we're seeing is these services, I saw code much like this in a client project. They'll say, OK, we're going to monitor your web performance. So they release a client. You add it to your plug library, and what happened was I was doing some performance analysis on a client project, and I traced it down to a service that I won't name, was just doing a GIN server cast on every plug request to some reporter backend. And that reporter backend was chunking those together, so it wasn't just sending a post request to the backend every request, but it was sending a message to a single GIN server process on every request that came into the app. So this actually crashed the VM when I hit it with traffic. So essentially, in an effort to measure performance, they reduced your application to single thread performance. So the number one goal of a data collection and metric library is that it can't take the app out under load. So like its job is to measure the performance under load, so it can't take the app out if it gets under load. So we want to solve this problem properly for all these providers, and then we can report the data to them. And they can do what they do best, which is visualizing the data, doing statistical analysis on it, all the great things that they're good at, without trying to reinvent the wheel. And for me personally, is I want to take this data then from the Phoenix side. So we have this boring metrics library, and this is just a Keynote table. So if you have experience with CSS and you want to help us make an awesome looking interface, please contact me. But one of my personal goals is, okay, if you're using any of these services, that's awesome, continue to use them. Phoenix is not going to replace them. But what I want to do is have an application out of the box have maybe a /performance endpoint, /metrics endpoint, that we can have this metric reporter be reporting to Phoenix, if you're running a Phoenix app, and it can expose actionable insights for non-experts. And for me, this is, again, this whole pit of success scenario where if you're, like, we have all these novel VM statistics, like the atom table, how many ETS tables you have, how many processes, and we have different system limits. So there's some interesting characteristics specific to the Erlang VM that most people aren't even aware of, at least if you're not an intermediate or expert user. So I want a user to, let's say, they see that their service is being restarted because of out-of-memory errors. That could be a pit of despair, where you're like, I was lied to. Elixir was immutable. It was supposed to stop memory leaks. Like, what is going on? It'd be nice if they were like, I have no idea what's going on, but oh, Phoenix has this /metrics thing, and then they were like, oh, Phoenix telling me something is wrong here. Like, this would be trivial for us to say, you know what? Like, we could show a message like this, like, whoa, there's a potential memory leak here. It looks like you are, oh, this was supposed to be expanded on the other exclamation point, so just pretend it's going off of the atoms. But we could say, like, well, your application might be leaking atoms. Like, this can happen if you're dynamically creating atoms from user input. And then you can also just show the Erlang docs and say, by default, the maximum is 1 million atoms, but if you know what you're doing, you want to increase it, you can pass this to the VM. Like, this information is out there, but being able to surface this and give non-experts insight would make an extreme difference. And then it would also make people feel like they're a wizard, because then it's like they just fix these errors in production, and we continue having them fall into that pit of success. So that's my personal goal with, we get the data collection part of it solved, we get the third-party data reporting solved, but then since we're collecting this data, we can surface a Phoenix, we can surface this in memory to a Phoenix process. So out of the box, you don't have to be running Grafana or Graphite, reporting to StatsD. You can just be running stock Phoenix Elixir, no dependencies, and get this kind of insight. I think this would be a huge deal. And monitoring metrics is pretty basic. It falls down into a few different types. One is we want to provide gauges. So like if you want to provide what's your CPU usage right now, you can report that, and we're going to sample that for you and then report it to these different services. We can measure requests per second, which is what you're going to want for a web request. That's done with a meter, so it's going to be a rate of event over time. And then these services can provide the statistical distribution for you. So Phoenix isn't going to try to replace, like I said, these services like New Relic, but we can provide information for a meter, and then you can see the statistical distribution, like what's my 99th percentile of request duration, and get that kind of insight. But what we will provide is this instrumenter layer, where a lot of people don't know about. Phoenix has a Phoenix endpoint instrumenter that lets you instrument different events happening in the framework. So we want to extract that into a more generalized part of the library that would just give you compile time hooks into application events. That way we can efficiently, like if someone says they want to instrument an Ecto query, they can hook into it and do that. That way Ecto doesn't have to worry about doing it the other way around. Like we don't have to tell Ecto itself to ask for the instrumenters. We can just handle it at the instrumentation level. And this is an early API. I showed a prototype of this working in Barcelona. So this is subject to change, but the goal is that you should just be able to write a function, and we should be able to collect data from it. So I should be able to say, I have a supervision tree here, and I want to start this CPU gauge that samples the CPU every second. And then I just define a function that uses existing Erlang VM modules to get the CPU information. And likewise, we want people to use this to surface whatever information they need. So they can say, okay, it would be nice to track my active users throughout the day. That way I can convince my investors to invest more money, because daily active users are really important. I can just do that with a Ecto repo query, right? So the goal is I should be able to trivially define these, give it the sample rate, and it's going to report that to my own New Relic backend, something my company's using internally, any adapter that wants to implement the data reporting. And then lastly, we're going to have a instrumenter that can say, I'm going to mark a meter. So Phoenix instrumentation will say, okay, every time a Phoenix endpoint controller is called, you can mark a meter to perform requests per second. So if I want to create a meter, I can just name it and say, hey, I'm going to take this thing every request per second. And then internally, when you call meter mark, hooking into our instrumenter in this case, it's going to use an ETS counter and make sure that's a very fast operation instead of the whole of like trying to do a gen server call and then introducing a bottleneck. And we also want to do some other neat development features. So since Elixir 1.5 got the IEX debugger that we saw this morning, we should just make use of it, right? If it's there, we should make use of it. So the easiest thing to do is in plug, we should introduce the ability to set a breakpoint from the browser. So imagine you get a beautiful looking error page like this, which is awesome. This is just the plug debugger, and then we can configure the Phoenix logo to show. But plug has a beautiful debugger now. We can step through the whole stack trace. We can see the lines of code and the code that the stack trace exists on, so it's awesome. But wouldn't it be nice if we could just actually click next to that stack trace line and say, well, set a breakpoint here. And then when you refresh the page, in your IEX prompt that you ran IEX mix Phoenix server, you have a breakpoint set. So we can do that. It would be no time for us to implement. And then I want to extend that idea to introduce a developer dashboard. And again, we want this to look super slick. So this is just a mock-up. And I have been playing with this in channels, but the idea is we want to have kind of like a Phoenix logger on steroids in the browser where you can say, there's a library now that, I forget the name of it, that shows you Phoenix statistics if you have a server-rendered app. But we want to consolidate that idea to like a / dashboard endpoint. That way, if you're developing a JSON API using GraphQL, you can see events that are happening in the app. So let's say I have a JSON API from my Ember app. We do a lot of Ember at Dockyard, and I get a crash. I don't have a server-rendered page to see that nice stack trace. So it would be nice for us to say, like, this 500 here, I've got my dashboard open, set a breakpoint there. Or be able to expand and get a pre-printed payload response. So these are things that Elixir has added recently, and we can make use of them to give you this nice developer experience instead of having to try to set those breakpoints manually yourself or figure out what's happening, especially in the application with a lot of traffic, like our workshop with Phoenix channels. We had a lot of channel traffic going on, so anytime there was a crash, by the time we try to look at it in the logs, it would be flooded in the scrollback. So it would be nice to have a Phoenix-specific logger happening, that way I can debug at the entry point of a web request. And another feature that we can implement very soon, actually I told Jose I would have a PR for it before the conference, and it hasn't happened, but what we've done at Dockyard is we do a lot of Ember, and the way we develop our single-page Ember apps is we have them isolated from our Phoenix JSON APIs. Separate repo, separate test suites, but we do have end-to-end tests. So one of the problems was our JavaScript end-to-end tests are painfully slow. And what we've solved, well, one of the reasons is we have to spawn headless browsers, and the headless browsers then have to call into our Phoenix app, but then all our tests are synchronous because we can't share a database transaction. So Elixir and Ecto have solved this with the Ecto sandbox if you're running a test within XUnit, but for end-to-end tests, there was no existing method to make use of it. So what we can do in JavaScript now at Dockyard is we can say, okay, before each test, this is, I think, a Mocha test library. I don't really write JavaScript, but this is a JavaScript test because of the way it is. But what we can do is we can say, okay, make an AJAX request and post out to sandbox checkout of the Phoenix app. And then after each test case, check that connection back in. So it's using the same semantics of Ecto sandbox checkout and check-in, but actually making a request to the physical server. And in the physical server, we just have a controller in our app right now that is calling into this Phoenix Ecto sandbox. So the Phoenix Ecto project will get this special sandbox support that will allow you to, within a web request, it's going to spawn a process that checks out a connection from the Ecto pool, and then it's going to send that back down in a header saying, here's a reference back to this checked out connection. So that way each test case from the headless browser is going to connect to the Phoenix, and we have a plug in our endpoint that's going to actually do an Ecto sandbox allow on our request process from that spawn process at the beginning of the test. And then at the end of the test, we just go to that check-in URL, and then we check the connection back in. And it's really neat because one of the things we're experimenting with is we can actually do fixture-based setup in our tests. So since it's just a Phoenix controller that we can control, we can write code in, we can say, okay, I want to test pro subscriptions in this app. So now I can have a concurrent test running in its own transaction, and I can seed fixture data for this test on a JavaScript side in a totally different project. So we can say, like, set up a param, like set up, we're going to call this pro. And then back in our controller, which is just a Phoenix controller, we say, okay, pattern match, if we have a setup, we're just going to call our factory and insert pro users. So within that test, it's running along with all the other Ember tests, but we have seeded data that we can test against. So this is like improving our tests by an order of magnitude. And Brian was supposed to have actual figures for me, but I will share those when we have them. But this has made an enormous difference for us. And this is something that took like almost no time to implement. So your JavaScript tests will be faster once we introduce this to the Phoenix Ecto project. And it should be very soon. And Jose will hold me to it. And another thing I want to call out is we had our first guide contribution sprint that I did not participate in. That's clear at this point, but other people did. This is a really neat effort that the Phoenix guides are an enormous effort that Lance Halverson started, and an incredibly enormous effort, because after the context guide, I reappreciated just how much time it takes to write solid documentation. So Willie Karam was kind enough to email the core team and try to get, and kind of let us know, like, hey, I can help with sponsorship, getting some of the Phoenix core team members here, sponsoring their trip here, and leading up an effort to work on the Phoenix guides during the workshop days, and trying to get the community involved, to have people that want to get involved with the framework and come in and we can work on the guides together. And this allows, well, one, the Phoenix core team to meet face-to-face, focus on the guide effort, but two, it allows the community to get involved in the project. So this is great because the guides, even if it's your first day in the framework, your input's valuable because we can have someone go through our guides from start to finish as a total newcomer and get that feedback that we all miss once we're kind of experts in the ecosystem. So our first guide sprint happened. We had a ton of closed issues, and we onboarded half a dozen new contributors, so you can get a contributor badge. We merged the Phoenix guides into the main Phoenix repo, which is pretty awesome. I was worried that Lance would have unseated me as a top Phoenix contributor with his commit count, but it didn't happen. If it had happened, I may have had to revert it. But the neat thing is, those commits are just as important. The Phoenix guide commits are they're part of the core of Phoenix, right? The guides, if we don't have solid guides, we're not going to get people into the community. But it's even cooler, though, that you can also come into the community and the guides on day one, submit a guide pull request for some issue you had, and get a contributor badge count to the Phoenix framework itself. So I think it's going to encourage contributions. And we also had multiple sponsors help sponsor this event. So I think going forward, this model of getting the core team together and getting the community involved through sponsorships is going to be a big help for the community. And so I really want to thank all the sponsors you see here for sponsoring Jason and Gary from the Phoenix core team to come out to the conference and lead up this guide effort. And I really want to thank Willie for kind of getting it all together, because I think this is a really solid and successful pattern that I'd love to follow in future conferences. So really shout out to these sponsors. And for me personally, like, the conference has been awesome as usual, but I've been kind of blown away by some of the use cases of Phoenix and Elixir. And I think, like, for me, like, my own personal goal is, like, Phoenix is like the plumbing to enable other neat things in the community. And I think, you know, Elixir and the Beam, like, you're right, every layer of abstraction in the Oreo stack, right? But really, the goal of that is, like, Phoenix, the goal isn't that we are going to have you, like, everything's going to be a Phoenix app. It's that we have this base of technology that Elixir provided us. We were able to implement a framework that is enabling people to build really, really neat things. So the apps in the project, for example, with Ben and Bruce, they have implemented GraphQL subscriptions on top of Phoenix PubSub and Phoenix channels, which, for one, is amazing because 2 years ago I said, GraphQL looks awesome. There's a ton of hard problems to solve, like around efficiently fetching data, and wouldn't it be cool if we could do this thing over Phoenix channels? And they did it all, and it works, and they solved all the hard problems for me, so thank you guys. And they have a book they just published, which is just out, so check that out. But for me, the coolest thing is I like to build things. Like, that's what I've always enjoyed, and that's like anything. Like, building software is fun. I'm into woodworking. Like, I just framed, like, I raised the floor in my living room, just like putting pieces of wood together. Like, that was awesome. So I just like to build things. So building a framework that allows other people to build cool things, I guess it kind of allows me to be lazy because now you can just do all the building. But the cool thing is it's enabled things that I didn't think was possible. And Keith highlighted this in his talk especially, and it kind of blew me away thinking in that light. So I knew that Phoenix enabled cool things to happen, GraphQL subscriptions, but if we take a higher level look at that, Keith is a self-described physician with software delusions of grandeur, self-taught, and he was able to use Phoenix Presence to write software to improve patient care, patient outcomes, and reduce errors in medical practice. So that kind of blew me away because it's like, okay, the software we write allows people to do cool things in web browsers, but here's a doctor that was able to say, wow, like all these things that weren't possible before, I can just grab Phoenix Presence off the shelf and apply this to literally improve the lives of patients and improve patient outcomes. And as Keith said, we have like thousands of deaths per year for errors that happen in just standard medical practices. And he wants to work on software that's going to solve those. And Elixir can help with that. So like I'm not even being like grandiose, like literally the tools that we work on as a community directly affect people's lives and can save people's lives. And we're enabling newcomers to come in and use these tools and allowing them to do things that otherwise weren't possible. So for me, that's been the coolest part of the conference. So whether like you're a physician with software delusions of grandeur, or if you're Tim, who has a wife with type 1 diabetes, he's a software developer, but he's like, I'm not a doctor. What the heck am I doing? I don't know how to, like, I want to make his wife wanted him to write a program to control her insulin pump in a closed loop. And again, her goal was to have improved quality of life by having a automatic regulation of her diabetes. And Tim came in saying, like, I don't know what I'm doing. I'm not a hardware programmer, but he was able to use a nerves project. And off the shelf was able to do something that previously just wouldn't have been possible given his background. And he was able to build this, and his wife's using it, piggybacking off the nerves project and other open source software, and it's directly improving her quality of life. So for me, this conference today specifically is like really internalize the impact that open source software can have. It used to be, wow, I allowed someone to build something cool in the web browser, but now it's like this community is enabling not only those cool things to happen in the web browser, but literally we're allowing people to achieve things that previously weren't possible or that they didn't think were possible. So I'm going to steal another quote from Keith, in that I think what we're doing is we're making the previously unachievable achievable. This is what Keith said this morning. From his point of view, as a doctor, not a technologist, but a self-taught programmer, these things weren't achievable for him before. He wasn't able to get into programming or use this replicated data structure, Phoenix Presence. Now that these things are off the shelf that he can use, now that nerves devices are off the shelf that I can just come into on day one and have an embedded program running, even though I have no background in hardware, I think like we're literally making the unachievable achievable. And I want people to really think about that when they're getting involved in the community, whether it's through answering Slack questions or sending PRs to Nerves or Phoenix or Elixir. I think that we really have something special here, and we can do amazing things. So that's the end of my talk. Thank you very much.